Now see a work done in an adiabatic expansion. Suppose you have taken gas in a cylinder whose walls are perfectly non-conducting, piston is frictionless and also non-conducting. 1 gram mole of ideal gas is taken here. Initial parameters are P1, V1 and T1. This is allowed to expand and it goes here piston by a distance of dx when this pressure remains constant for this small interval of time. So, we can take work done by the gas dW is equal to F dx. So, dW is equal to pressure into A dx. A into dx is here the small change in volume. So, we can write here dW is equal to P dV. Now, if you want to calculate total work done, if this thing is changing V1 to V2, here T1 is that is also changing here T1 to T2 and pressure is changing from here P2. These are the parameters. So, now the work done here we know it PV raised to power gamma is equal to constant, that is equal to some constant K. So, we can write here P is equal to K upon V raised to power gamma. So, we will be getting dW is equal to K upon V raised to power gamma here, that is into dV. Now, if you want to get the total work done in changing the temperature in changing the volume from V1 to V2, so we have to integrate it. So, now see here this is the work done here for displacing the piston by a small distance, that means for changing the volume by dV. Now, the total work done in changing the volume V1 to V2, we can write W is equal to K V raised to power minus gamma dV V1 to V2. That can be written K V raised to power minus gamma plus 1 upon minus gamma plus 1 V1 to V2. So, we can write here K upon 1 minus gamma into V2 raised to power 1 minus gamma minus V1 raised to power 1 minus gamma. This is the work done. Now, here in place of K also we can write here P1 V1 raised to power gamma is equal to P2 V2 raised to power gamma is equal to K. So, that will be here W is equal to 1 upon 1 minus gamma P2 V2 raised to power gamma and V2 raised to power 1 minus gamma minus P1 V1 raised to power gamma and V1 raised to power 1 minus gamma. Now, in this case we can write 1 upon 1 minus gamma. If you solve it, you will be getting here P2 V2 minus P1 V1. And now, in place of P2 V2 we can write 1 upon 1 minus gamma RT2 minus RT1. So, we can write here R into T2 minus T1 upon 1 minus gamma. So, this is the formula for work done in changing the temperature from T1 to T2 or changing the volume from V1 to V2 in case of adiabatic process.